So we're going to start with complex zeros. This is phase one, and we're pulling these problems right out of the book. So if you have your book, go to page 134, look at the try these A, and then look at little a. This is the problem that we're doing. And one of the things that we need to do is just make sure we follow that pattern of questioning to get us to sketch these correctly. And the first thing that we need to ask ourselves is, what degree is this? So the highest exponent in this entire polynomial is a 3. And because it's a third degree polynomial, automatically that makes it a cubic. The next thing we want to do is check out the end behavior. The end behavior tells us what the sketch of it is going to look like. And for A, we have to decide whether it's positive or negative. So when I look at my leading term and my leading coefficient, it's positive. So A is going to be positive 3. And since A is positive and I know that it's a cubic, it's going to look like that or something similar to that. The next thing we have to do is we need to find our y-intercept. And our y-intercept is 0, the constant. And our constant is our end term without the variable, which is negative 8. The last and most important piece of finding the sketch out is the X-intercepts, also known as the zeros. So for X-intercepts, I need to solve this by factoring. Now it's got 4 terms in it, which leads us right into factor by grouping. So the first thing I'm going to do is I'm going to write my problem down. 3x to the third minus 2x squared plus 12x minus 8. Then what I'm going to do is, because I need to do factor by grouping because it's 4 terms, I'm going to crinkle cut right down the middle here so that I can GCF the left and GCF the right and then put it back together. The GCF of the left, well, the left has x squared amount. That's in common. And you'll get 3x minus 2 left. On the right side, the common factor is a positive 4. And when you divide the 4 through, you get 3x minus 2. So I know I'm on the right track because these are common, and that is our first factor. And then we take our GCFs and we smash them together to make our second factor. Now, our GCF is x squared, and then this is a positive 4. I want to pause here for a second and make sure that you understand that you cannot factor this x squared plus 4. This is a sum, it's a positive, and you cannot factor it with a square root, like a difference of perfect squares, because it's a plus. So we have to go ahead and solve these by setting them equal to 0, and this one we're going to have to solve by isolating the x. So now I'm going to take my 3x minus 2 and set it equal to 0, and my x squared plus 4 and set it equal to 0. And I'm going to solve each of them for x. When I solve the 3x minus 2 equals 0, I'm going to do my additive inverse to get 2 on the other side, and then divide by 3 to get x alone. And I get x is 2/3. So there's a root. There's a solution. That's a 0. That's where it's going to cross the x-axis. When I do this one, I need to get the x squared by itself. So I'm going to subtract 4 on both sides. And there it is. That's what I've been waiting for. 0 minus 4 is negative 4. I'm looking for complex zeros. And there it is, because when I take the square root of a negative number, I'm going to generate an imaginary component I. And the square root of 4 is 2. Don't forget that you also need a plus or minus here. So when I go to write my answer, x equals plus or minus, I'm taking the square root of 4, which is 2, and the square root of a negative, which is I. So because I have a degree 3, I should anticipate 3 solutions. 2/3 is my first solution, positive 2i is my second solution, and then negative 2i is my third solution. So far, so good. Now, the only thing is we have to be able to sketch this. I know that my y-intercept is at 0, negative 8. So I'm going to go down on my y on the negative end, and I'm going to put a dot at negative 8. I'm going to label it like that. 2/3 is one of my roots. So if I put a 1 here, 2/3 is between 0 and 1, so I'm just going to put that there. That's a good indicator. And if you're wondering how to plot a 2i or a negative 2i, you can't. It's imaginary. So I need to come up with a shape that kind of resembles this. And I'm not sure if it's going to be down here, in the middle here, or up here to make the squiggle happen. I'll probably just start at the bottom, connect these two, do my wiggle, and then go up like that. I'm not sure where this little turn is going to happen. It could be in any one of these 3 spots. So the important piece is that you know that it's in this shape. You've got one X-intercept that's real. You've got your Y-intercept, and you've got arrows on it. And that's how you do this problem.